This video is on analytical techniques to identify organic molecules. Organic molecules are very distinguishable when drawn on paper, but when it comes to identifying them in real life, it becomes a lot more difficult because most of them are clear liquids or white powders. Luckily for us, there are multiple techniques to choose from to be able to identify what chemical something is. The most common techniques used in organic chemistry are liquid chromatography or gas chromatography, shortened to LC or GC, mass spectroscopy, shortened to MS when combined with other things, infrared spectroscopy, often known as IR spectroscopy, ultraviolet and visible light spectroscopy, often shortened to UV-Vis spec, and finally, nuclear magnetic resonance spectroscopy, often shortened to NMR spec. Liquid or gas chromatography are both like thin layer chromatography on steroids. They separate the components of a mixture by having a mobile phase and a stationary phase. The mobile phase is either a liquid or a gas. Of course, just like TLC, you require a standard to compare your results with to truly know what you are looking at. Mass spectroscopy identifies the mass of your compounds or the masses of the fragments of your compound because we're just blowing up the molecule and seeing what the chunks are by mass. Of course, here you need to have something to work with and have somewhat of an idea what you have, because if not, many things can have the same mass. This can be partially solved by using high definition mass spec, where we have exact atomic masses to multiple decimal places, but we still run into the issue that constitutional isomers have the exact same mass but have different orders. IR spectroscopy identifies functional groups present, so it is more of a is it there type of technique as opposed to what the structure of it is. So for example, if you had an alcohol, you would detect the alcohol functional group on the IR, but you would be unlikely to be able to tell what the rest of the structure looks like. You could also tell from it though that you do not have, say, a ketone in there if you are missing the data implying a ketone is present. UV-Vis spectroscopy is extremely useful for conjugation, and that allows you to identify specific molecules, but if your molecule doesn't have conjugation, it is a useless technique. And finally, NMR spectroscopy is pretty much an MRI on your molecules. Literally, it is the same instrument except on a smaller scale so that you can only put a chemical sample in it as opposed to a person. Sure, the magnets are a bit stronger also, so it would probably harm a person if they were to fit in one. Anyway, NMR gives you the structure of the molecule. It will tell you how certain atoms are arranged around each other so you can actually get a pretty good picture of what your molecule looks like. However, even NMR is not perfect, and usually you need to combine multiple of these methods to be able to characterize an unknown compound. What do we mean by characterize? We mean by identifying the unknown. So if I gave you a vial of a clear liquid, you would have to combine multiple of these methods to be able to identify what it is.